This is the review for the similar figures and dilations retest review. This is a review. We're going to start with number 7 here since we did a lot of this in class today. All right, on number 7, and this is on the review, you should have, if you're doing the retest, you should have your original test, which you're going to make corrections on, sitting right next to this review, because problem number 7 on the review and problem number 7 on the test are worked the same way. Okay, so number 7 on the review says the measurements of the rectangle shown, measurements of the rectangle below are given. Which set of measurements listed would produce a similar rectangle? Well, similar figures have proportional side lengths. So you could set up a you could test the relationship between these two and see if these two produce the same relationship, or set up a proportion and figure out what's going on between the corresponding widths and lengths. Since this number is smaller than this number, if we call this one the width and this one the length, then all of these smaller ones would correspond to the widths also. All of these in this column are smaller than these here. These would be your widths. So you could use ratios if you wanted to, or set up proportions where if you took like this width here of 25 and compared it to the length of 30, you could do that in the given sign and see how that compares to a width of 10 to a length of 12. If they are similar, you're going to get similar ratios. Well, 25 over 30, they're both divisible by 5. 25 divided by 5 is 5, and 30 divided by 5 is 6. So the ratio of the width to the length is 5 to 6. Is this 5 to 6? Well, if you divide this by, let's see, they're both divisible by what, 2? That reduces to 5, and this one reduces to 6, and it appears to be similar. Okay, let's check it out here. I just want to make sure that, that's the right one. How about 15 to 20? If I reduce 15 to 20, they're both divisible by 5. I get 3 over 4. And that's not equal to 5 over 6, so it can't be that. How about 20 over 26? Oops, let me put that up here. 20 over 26. 20 to 26. They're both divisible by 2. You get 10 over 13. Nope, that's not 5/6. So that's not going to work. And let's try 30 over 40. Those are both divisible by 10, and you get 3 over 4. Not the same ratio, so I know it's A. You guys could have also set up, the proportion this way. You could have said 25 in the given is to 10 in that choice right there, as 30 is in the sign over the length of 12 here, and done your cross multiplication. That's 300, 12 groups of 25, that's 300 also. It's got to be A. All right, number 8. At a certain time of the day, a shadow of a 3-foot girl is 4 feet long. The shadow of a lighthouse at the same time of day is shown below. How tall is the lighthouse? That's what we don't know. Okay, so I'm going to set up a proportion. I know they're similar because the sun is shining and creating similar figures. So I'm going to compare the small rectangle maybe to the large triangle and set up a proportion. 3 in the small rectangle corresponds to X in the large. 4 in the small rectangle corresponds to this total length in the large, which is what? You got to take the 4 plus the 36 and you get what? Yeah. Now you're going to cross multiply to solve. All right? You figure that out on your own. And there is an answer bank. Check your answers in the answer bank. What is the distance across Eagle Lake using indirect measurement? Okay, here's Eagle Lake. We're going to call that length X. And I'm going to call that my small, and this one's my big rectangle. And anytime you've got this kind of setup, they're similar or similar triangles. So they're small to big. I'm going to pick a length in the small. I'm going to pick 4 in the small. That corresponds to x in the big. 6 in the small corresponds to 27 in the big. How do you solve a proportion? Yes, you cross multiply. Okay, don't forget to find the decimal point in your answer so you can fill in your griddable. Number 10. A scale drawing of a rectangular room has a length of 12 inches and a width of 8 inches. That's the drawing. The scale factor from the drawing to the actual room is 36. Find the length in feet of the baseboard needed to go around the actual room. Okay? Well, I know if I take my original lengths and widths and multiply by the scale factor, I get my new lengths and widths. Now, one thing I know about similar figures, and I know they're similar because I'm applying a scale factor and I'm going to create similar rectangles, I know that perimeters are also proportional. So if I'm going to find the length of the feet, length in feet of baseboard that goes around the actual room, we're talking perimeter. So I'm going to find the perimeter of my little drawing here, which is 8 plus 12 plus another 8 plus another 12. Well, 8 plus 12 is 20, and 20 plus 20 is 40. So the perimeter on the drawing is 40 inches. I can take my perimeter of the drawing and multiply by my scale factor and get the perimeter of the actual room, but that's going to be in inches because this is in inches. Okay? Once you multiply this out and find out what your perimeter is for your room in inches, then you've got to convert it to feet. And how do you convert it to feet? Yeah, take the answer in the box and divide by 12. That's what you're going to do on number 10. Number 11, Mrs. Tucker placed a shape of an equilateral triangle under the document camera. This one right here. The document camera dilated the triangle's image on the screen by a scale factor of 4.5. If the length of one side of the original triangle is 3.25 centimeters, what is the length in centimeters of each side of the dilated triangle on the screen? Okay, well, here's your original, your projection is your new, and I know the original length multiplied by the scale factor equals my new length. So my original length is 3.25. I'm going to multiply by my scale factor of 4.5, and I will have my answer in centimeters. All right. Number 12. You have a picture of Mickey Mouse that you need to copy. You set the copy machine to reduce the picture by 40%. How tall is the original Mickey? Okay, here's the original Mickey. If I take the original Mickey, his height, let's call it h. His height multiplied by the scale factor equals the new height. And the new height, the dilated height, is 5.5. Okay? Now scale factor, if we're going to set the machine to make it 40% of the original height, we're going to reduce it down is what we're going to do. My scale factor is not 40%. I've got to change 40% to decimal form. And 40% in decimal form is 0.4. So that's what my scale factor is. So some height multiplied by 0.4 gives me 5.5. If this number times this number gives me that for an answer, how do I find this number? Yeah, I'm going to take 5.5 and divide by 0.4. And that's how you're going to get your height. Okay, so you guys work that out. 13. Triangle ABC is dilated to form triangle A prime, B prime, C prime. Okay, it looks like the original is on the inside. The dilated is enlarged. They want to know which number best represents the scale factor to change A, B, C into A prime, B prime, C prime. Since the new is larger than the original, I know my scale factor has to be what? It has to be greater than 1. Well, that one's greater than 1, and that one's greater than 1, and that one's greater than 1, but that one's not. So cross that off. Okay? I know that scale factor equals new length divided by original length. It also works for coordinates of points on a coordinate grid like this. So I think what I'll do is I'm going to list the coordinates of A. You could do this with B or C. And list the coordinates of A prime and look to see what I multiplied A by to turn it into A prime. Okay, look at your scale here. A is at -2, +1, 2, 4, 6, 8. -2, +8. A prime, if you're looking at your scale, is at -3, 2, 4, 6, 8, 10, 12. All right, this is your new, and this is your original. I can still use this with the coordinates. Take that x coordinate there, divide it by the original x coordinate there. A negative divided by negative is positive, and my answer is going to be 3/2. 3/2, that's the answer. Okay? Or 1.5, same as 1.5. 14. Disregard 15 for the minute, we're just looking at 14. Triangle A prime, B prime, C prime, this one right here is a dilation of triangle A, B, C. What is the length of x? If it's a dilation, it creates similar triangles. So I'm going to compare small to big or large and set up a proportion. You could also figure out what the scale factor is that turns 5 into 12.5, or 6 multiplied by what gives you 15. If you can figure that out, then you're going to multiply by 2, or you can set up a proportion. 2 in the small corresponds to x in the large. Go back to the small. I'm going to pick 6 in the small, corresponds to 15 in the large, and cross multiply. Well, you don't even have to cross multiply. Look at the relationship here. You multiplied by 3 going this way, so guess what you're going to do this way? Yeah, divide by 3. And your answer is going to be what? Yep, I knew you knew it. All right, down here, number 15. Mrs. Bailey just enlarged a picture to 18 inches by 36 inches. If this enlargement is 2 1/4 times the size of the original, here's the original, and you know these are supposed to be similar figures. This is the new, and you take the original and you multiply by the scale factor to get the new. They want to know what's the closest to the dimensions of the original picture. Well, if I want to know my length and my width, I take the original, multiply by the scale factor, and I get the new. Well, what are you going to have to do? You're going to have to go in reverse to calculate, start with the new, go backwards to get the original. If I were to take my width, multiply by 2 1/4, I would get 18. How do I do that in reverse to decide what W is? Yeah, W is going to be this answer, 18 divided by 2 1/4. You'll do that to get the width. You'll do the same thing to get the length. Take the 36. If some length multiplied by your scale factor of 2 1/4 equals 36, how do you figure out what the length is? Yeah, take 36 and divide by 2 1/4. Okay? Two similar triangular prisms is shown below. What's the scale factor from the small prism to the large? What's the scale factor going in that direction? Scale factor equals new over original. So let's pick some lengths here, and the only one I can pick is this one. That's the original, 8. The corresponding new length is 13.6. Divide that out and you'll have your scale factor. That's the first thing I want. That answer goes here. And it says what's the value of x in the smaller prism? Just set up a proportion. 8 in the small corresponds to 13